Good morning, everybody. The contest is now starting. I'm Kamil Dębowski, or Erichto, and I will comment today for the next 5 hours. At the bottom of the screen you can see some links like the scoreboard and mirror contest, where you can access PDF statements of all the problems. We have 100 teams from 50 different institutions. Yesterday there was a 2-hour practice session. In the evening the banquet, with also some sightseeing next to Eiffel Tower. And today the real contest. There are 12 problems. Short summary of rules. For 5 hours, 3 team members have access to one computer, and they have 12 problems to solve. Because there is just one computer, they need to smartly choose who should have access to it. Maybe 2 or 3 team members at the same time, they want to implement something to submit a problem, but they should decide who of them has the shortest code in order to get that accepted first. If there is a tie at the end between multiple teams with the same number of problems solved, the total time counts, the sum of solving times for all the problems. So if one team solves one problem in 10 minutes and next problem in 60 minutes from the start, their total time will be 10 plus 60, which is 70. If some other team solves 2 problems after 60 minutes, their total time penalty is 120. So this means it's good to solve easy problems first, and participants should follow the leaderboard, and if they know how to solve some hard problem, but they see an easier one apparently has a lot of submissions, correct submissions, they should switch to that one. Hello everybody in the chat in YouTube and in Twitch. During the contest we will talk about some problems. We expect especially 2 problems to be solved very quickly. If you see already on the screen some teams implementing something, it's either their templates, headers for different languages, setting their software, because they start today, even though there was a practice session yesterday and they could configure everything. Today they start from clean machine state. Nothing is saved there. It's just like if you installed, say, Ubuntu or whatever system they have. And it means you need to first configure some stuff like Vim or your favorite IDE. This is one thing, and the other is you might want to type already some headers that you often use. Some teams will have more than 50 or 100 lines of pre-written code in order to speed up their implementation later. If you can once spend 1 minute or maybe 3 minutes, and then thanks to that, for each of 12 problems, save 30 seconds, it's worth it. Yeah, so either that, they are configuring and typing their headers, or they just found one of those very easy problems. And we already have 2 submissions for problem I, 2 correct submissions. They are not displayed right now on the screen. Were they?
It's working. We are working on it.
Yeah. And we are working on the scoreboard. Then from time to time you will see that on the screen, but there are links on the bottom. Problem I, which was accepted now 4 times, was indeed expected to be the easiest one. Then there's problem B. Can I get PDFs here, like in Discord?
Public mirror. problem set and stuff.
What you see right now on the screen is problem I, which is called rats. And there is some formula given in the statement. You are given three values, n1, n2, n12, or n12, with some small constraints, and you need to find this formula. And the only thing you need to be careful about here is to take the floor of the answer, not some real value. And this can be for sure implemented in seconds. So what do we have for the sample test here? We have n1 and n2, and plugging this into formula, it's 16 times 19 divided by the third number, 11 plus 1, 12, minus 1, and then you take the floor. But in many languages, including C++, if you just type 16 times 19 divided by 12, the floor will be taken by default. So this will be a correct solution in C++. You can just print this. After, of course, reading where obviously those three numbers are variables. It wasn't hard to predict that this would be the easiest problem of the contest. Is there a number of submissions like at the bottom? 23? We have 23 accepted submissions for I, and several accepted submissions for B, but also some incorrect ones. I is a problem hard to solve incorrectly, but B, on the contrary, has some wrong submissions already. Problem B is about biodiversity. In this problem, there are several animals in the garden, in a huge garden, as the statement says. And given their description, and the number of animals, and then their names, like mouse, you need to find if one animal, if there are more of one animal than of everybody else. Right now on the screen you see a lot of submissions, everything from the start of the contest till now. Our system has just started working. Mostly those are correct submissions for I and B, but we have a correct submission from Technion Rubber Duck for C. It's also a team that was winning for the most time yesterday during the practice session. We will for sure see some more submissions for B and I in the next half an hour. Then most of the teams should be done with those two. Let's remember that even though it's very easy for us to solve such a problem, the teams are presented with 12 problems. Their statements aren't really that short, so it's hard to find at the beginning those easiest problems. And also it's hard to switch. If you read some problem and are in the middle of thinking about it, you might lose some momentum if you then switch for an easier one, even if you see from the leaderboard that it is easy. This is the current leaderboard with UPC1 and Technion Rubber Duck almost tied for the first place with very similar time penalty. The two most important columns you see here is the number of problems solved, the sigma, here usually 1, and then the total time penalty, which is roughly the sum of submissions for solved problems, with some small time penalty of 20 minutes for every incorrect submission for a problem which you solve later eventually. Back to the biodiversity problem. Given, for example, 4 and rat, mouse again, and a dog, given those 4 animals, you should say that none of them dominates the others, because we want one animal to be strictly more than everything else. And here you need to be careful. Fortunately, one of the sample tests checks that, so it isn't that easy to make a mistake. It's of course the decision made by organizers, how tricky they want a problem to be. Sometimes on purpose they will only provide a simple sample test, like saying for this input with, say, rat, mouse, and say again mouse, the answer is yes, mouse is dominating the whole garden. And then a lot of teams will get that wrong, because, for example, they will say something greater than or equal than everything else, and that will be incorrect for our previous test. During a contest, it's your responsibility, a participant's responsibility, to test your program a little bit, because if you submit something incorrect, you risk that 20-minute time penalty and also some loss of momentum. You'll think that this problem is solved. You maybe should already start reading the next one if you don't want to waste time, and then you need to get back to that one. Can they print their codes?
They can print.
It's a very important skill during team contest is not to waste computer time, and this is why participants can print their codes. If something doesn't work, a programmer usually can test their solution using a computer, and you can also do that here. But if your teammate has some other problem to solve, and it is usually a case at the beginning of a contest where they see a bunch of easy problems, you shouldn't really stare at the code or even run some tests on your computer. You should print the code, then work with that on a piece of paper. Read your code again and again, think about some tests, and maybe then once you prepare a test that you think is incorrect, then take a computer and try that test. And maybe make a fix if you already found that on a piece of paper. In C++, the easiest way to solve this problem B is to use a map. For every string you will have a counter. The same can be done with dictionary in Python. And at the end, you want, you basically, for every entry in this map or dictionary, you can check if count of this entry is greater than half of everything. If you do it this way, it's very dangerous because you have some division. Let's see if it will work. For n equal to 6, this would be a 3, so correct. For n equal to 7, this will be again a 3, so it turns out to be a correct check. But something like that is dangerous, and it's safer to move a 2 to the left side, and this would be a check I would use. For every entry in the dictionary, check if twice the count of this animal is greater than n. If yes, then print the name, because you print here a string that appears a number of times that is greater than the sum of others. So you print this name and finish. If you didn't finish even once, you print at the end a word none. That was problem B. In the middle of a contest, we expect fewer submissions, like every second or minute. It's quite natural if now you have problems solvable in a minute, and later they need to spend half an hour for medium and hard problems. We have accepted F from team UPC1, Universitat Politècnica de Catalunya. We see some clarification on their screen. During a contest, if a participant isn't sure about something in the statement, if they have a question, it's not just about raising your hand, because judges, the people who know the problems, they sit in some judge room and they monitor the whole contest. They check if everything is correct, if there are no issues, and you can type a clarification request and they will answer eventually. It's not just about raising hand and getting some answer from whoever is in your room. This must be official, and from time to time, if really there is an issue in some statement, there will be a public announcement. For example, we have a typo in this statement. Instead of 1, there should be a number 3 in this explanation of the sample test. This is never a big issue. It's of course a big issue when there is something wrong with test data or with the intended solution. It happens once maybe every 50 contests, and you can never be sure. You can check something 10 times and still get some mistakes. Imagine writing an English essay and it being checked by several people. This is what happens for those programming contests. Somebody prepares a problem, prepares tests for that problem, and other people check after the first person in something very important and big like World Finals. Around 4 people independently work on a problem, on each problem, and usually those are different sets of people. But there are mistakes caused by kind of an intuition that this looks correct, and nobody will think that it might be wrong. There are other tools to prevent the biggest mistakes, like an incorrect data. When you create test input files for participants, there is a program called Input Validator. It's not that you type. Organizers don't just write generator program, which would generate huge test files. Nobody prepares those tests with rat, mouse, dog, and so on, and 100,000 entries by hand. There might be a few small sample tests made by hand, but most of them will be created by a generator program, and one can make a mistake in generator program. especially for hard problems where such a generator can be very complicated. And this is why you have input validator, a separate program which should say error when there is something wrong with input. And that program will read the input character by character, not even ignoring white spaces. And if there is anything wrong, including an unnecessary space at the end of a line, it will say error, correct the input data. We have here solved problems F, C, B, and I. Rubber Duck Forces, also one of the top teams with BCI, solved in first 9 minutes. Now submitting, printing. And they like to name their program swerts_cpp.cpp. The organizers and commentators strongly prefer when teams use meaningful names of their files, because then it's easier to see what they are working on. Here we have f.cpp, so easier to understand than swerts_cpp.cpp. Print area plus 0.25. This is for sure to round the answer down. If the double value is, say, 17, and you want to print that as an integer, rounding in C++ by default rounds down. And if you computed something as 17.0, maybe there will be small precision error, which often happens with real values when you deal with real values. And instead of 17, the value will be 16 point, a lot of 9s, 9999998. Then it's better to add some small value and then print rounded down. There are also functions for that, like round, or even better LL round, which takes a value and returns a long log, closest to the given value. Let's talk about problem F in a moment. F is called Icebergs and is about polygons on the plane. It's also a skill for participants to quickly read the statements and understand what really is important there. Sometimes the statement is very long, but it can be described in just a few sentences. And for a single problem, it doesn't matter much if you spend 1 minute or maybe 5 minutes reading it, but for 12 problems, it adds up. Problem F. Not a hard one if you have a lot of experience in competitive programming, but maybe harder for your everyday programmer who doesn't often deal with stuff like this. You're given some polygons described by their vertices, and you need to find the total area of those polygons. This is F. Icebergs. Very important thing here is that polygons do not intersect. If this situation would be possible with one polygon and then the other, maybe participants would need to deal with those intersections in some special way. If the statement said that this is area of iceberg, this is also area of iceberg, but you need to compute the total area of land covered by iceberg, well, sea covered by iceberg, that would be harder, but it is not possible. Polygons are disjoint, and then the problem boils down to computing the area of a single polygon. And the simplest and very standard way to deal with that is to imagine that the polygon is split into triangles, and there is a formula using cross product for area of a triangle. So every such thing, the area of this, is a simple cross product which involves this formula. x1 times y2 minus x2 times y1. Where those are x1 and y1 are coordinates of one vector, say a segment of a triangle. When you really understand cross product, actually even there is no thinking about this point. It can be just 0.00, but that saves just half a minute. Wrong answer, can you see? We will discuss problem C solution in a moment. Also, some top teams they try to solve problem K without a success so far. And solving K now isn't a stupid thing to do. It's right in the middle of difficulty expected by the organizers. Problem C is called ANS. And it's one of those problems where the statement and the story isn't that important. And it's good to quickly rush through it and just understand what they ask about and implement that. This is sample input and output for this problem. And given a bunch of numbers, here it will turn out that those are most important here, but given n numbers, n is up to 1 million, and then n numbers, you need to find the smallest natural number, non-negative integer, not present in this set of numbers. Because 0 is already here, 1 is already here, the answer is 2. If the input in some order contained numbers 3, 1, 0, 5, 6, 4, then still the answer would be 2. Right now the answer would be 7, because all numbers 0 through 6 are present in the input. The catch here, and this can cause a lot of troubles, is that every number from the input, say AI, can have up to 100 digits. So this is up to 10 to 100. Well, exactly 10 to 100 would have 101 digits, so here actually it's strictly smaller. A number has up to 100 digits, and in some programming languages you cannot simply read such a big number. C++ is one of those languages. C++ is the favorite language of especially teams in the top, in the whole competitive programming world. And here you can, in C++, what you can do is read this number as a string. If it has more than 9 digits, or actually just 6 or 7 digits, then ignore it. A huge number will not change the answer. You can ignore such a number. Otherwise, you can, let's say, then cast it into int. There are functions to do that, like ATOI or STOI, things that turn string into an int, or a long if you wish. And maybe here the optimal thing to do is to just switch for this single problem to, say, Python. And Python already supports big integers. And once you get rid of big integers, of those longer than 6 or 7 digits, you can either have a set or a dictionary, put all the numbers from the input there, and then iterate from 0 up and check for each of those numbers if it is not present in the set. If it is not, then print it and terminate. We see some wrong answers and random errors for C. This is problem C, which is called ANS. In C++, this solution with a set will be n log n. You can use a hash map, a hash set, an ordered set, but it's always dangerous. Maybe organizers prepared some very strange test with a lot of hash collision. You must be careful with that in programming contests. So actually set is safer, even though it's slower by logarithm. But also you can create some array. You can create Boolean array, exists, let's say, of size n, maybe n+1. And every time you read a number in this reasonable range from 0 to n, you mark exists of a as true. And then you do the same thing as we did earlier. Iterate over the numbers from 0 to infinity, but you will stop eventually. And if this number does not exist, then print it and finish. Did submissions disappear? I don't see anything for the past 2 minutes. Doesn't look like any things. Talking a moment. We'll get back to analyzing problems and also talking about the whole structure of ICPC, this whole competition, like regionals, world finals, in around 5 to 10 minutes. For now, enjoy screens of the top teams and also a random camera where you can see how the participants struggle. See you in 10 minutes. I'm back with the commentary. If you wonder what are the balloons in the room, actually this tradition in ICPC dates back to many years ago, where right now we have leaderboards, we have internet access, everybody, including participants, can easily see what are the current scores and which problems they should solve. But in some of the first editions, balloons were indication of which team is good and what problems you should solve right now, because participants did not have access to automatically maintained leaderboard. Actually, nothing was that automated. Somebody had to go and show their code to the judges. It was much harder. And right now, every balloon that you see represents one correctly solved problem. And here we see a lot of green, a lot of red, likely those are I and B, maybe respectively.
And J is solved.
And J is solved for the first time by ENS Ulm 1.
The winner from last year.
As I've just heard, this is the winner from last year, and then I think also from previous 3 years. It's the same university, but it is the same team from the previous year. So these are regionals for ICPC. The contest consisting of a lot of stages. Usually there are some sub-regionals in your, maybe in your country or just in your part of the country, where some teams are chosen. Maybe before that, in every university, if there are a lot of teams wanting to participate, there will be some qualification round as well. But this is the second last stage, regionals. Here we have several countries like France, Italy participating. And then there are global world finals happening once every year. It isn't easy to advance there. And also, this is only competition for universities, and you can participate in the world finals only twice. This is to prevent some regions from dominating the stage, because there are some countries with very strong algorithms and competitive programming culture. They would be always in the top, and if you get some strong team, they would maybe win every time for 4 or 3 consecutive years. So here there are some limits. Because of that, sometimes it's optimal for you if you are, let's say, if you are not in your last year of university, you should skip a year. We see 2 teams here, UPC1 and ENS, with 5 problems. Each of those solved K or J, and also they have 4 problems. There's one team on the 14th place with A. They didn't solve F yet. Maybe we'll see in a moment them jumping to the top. If they get 52 minutes penalty, that puts them at 130 plus 20 minutes for wrong submission. That's 150. So they will get above ENS team. UPC unsuccessfully submitting problem G. Also a lot of incorrect submissions for K. So right now UPC looking strong. Then Uni boys will likely get the second place in a moment. Maybe not that likely. Still a lot of teams can get the second place before them. Especially EP Chopper with only 42 total time penalty. Again, this is the sum of submission times of correctly solved problems. If you don't solve a problem, you aren't hurt by your wrong submissions. So even if you have 20 wrong submissions for a problem, it's not that it is automatically 20 times 20 for 100 minutes of penalty. Only if you solve a problem, it starts being counted. And it's always better to have one more problem. You cannot be hurt in the leaderboard. You cannot fall back in the leaderboard by submitting a problem with a lot of incorrect submissions. We see here a printout command for G. So somebody solved G. They wanted to make the computer available if somebody else wants to type something. This is why there's a printout. But if nobody is using a computer, they shouldn't just use a piece of paper. They should test. Maybe this is more efficient. We see here h.cpp with some bitwise operations. École Polytechnique solving K, I think it's case.cpp. École Normale de Lyon, also with solving H. Let's then maybe talk about it, even though it isn't solved yet. But nobody forbids us from solving a problem before the participants. And if you ever do not see for some time the submission list in bottom left, then it's good to follow the current situation, to just use the link at the bottom. You will also always get the updated version then there, just in case our system hangs for a moment. Some last looks at the screens. Team UM greedy to bronze. We see in the terminal here just submitting their codes. Submit c.cpp, submit f.cpp. They can use UI. They can just go to the website of the competition and choose the file submitted, but also it is possible in ICPC to just submit from your terminal. And well, programmers like to use just the terminal. They don't have to click anything, they can just type. Same for printout. So if you don't want to follow the leaderboard, I think you are okay not using the browser at all during the contest. Obviously, they don't have access to the internet. They have just access to internal network with competition site. This is problem H, called pseudo-random number generator. Pseudo-random number generator. Let's call it pseudo RNG, where you're given the first value of some sequence, like here, this is some number, and transition to the next number. Things are computed modulo This is 2 power 40. Well, you can also see it on the right. And we need to say something about first n numbers of this long sequence. N is huge. N is up to 2 to 63, which is around 10 to 18. A bit more than that. This basically just is a number that fits in long time. And when you're given a sequence where every next number depends from the previous one, you can think about it as a graph. For every number, you know where you will go next. So it's a graph. From every number, you have just one edge out. And such a graph with just 2 to 40 vertices or nodes, it must have a cycle. You start from something, say a number 10. You move to something else. Obviously, those numbers should be much bigger, but I don't want to type so much. Then maybe you will go to 5, 7, 2, and maybe then back to 5. So for some time you will follow a path, and then for the first time you will enter a number where you already were, and this is a cycle. Now forever you go in that cycle, and because the number of vertices is limited by m, every number is from 0 to m minus 1, the size of this graph is only 2 to 40. Then there is cycle, so actually this limit for n doesn't matter, and from complexity O of n, we already got to complexity O of m, which is slightly better. Still not good enough. And this is one of those problems where you shouldn't just solve it on a piece of paper. You have computer and you can check something. Here what you should check is you should actually run this program and check when you for the first time hit the cycle. The complexity O of m, so around 2 to 40, which is around 10 to 12 operations, it should take roughly, maybe not roughly, but this is the magnitude, 1000 seconds. Because a second is enough to do 1 billion very simple operations. And operations that you see here, like adding, shifting by bitwise, computing modulo, a power of 2, those are all simple operations. So you can almost say that you can handle 1 billion operations in 1 second, maybe slightly fewer than that. 1000 seconds is, this takes minutes. 1 hour has 3600 seconds. So let's assume that this takes less than 1 hour. So what you can do? Well, you can run this and tell your program to check when there will be a cycle and print that moment. It would be nice to get a short time to that cycle and maybe also a short cycle. How to check if something was already there? Well, this is a harder part, because you cannot have that big memory. If you have, say, 4 gigabytes or whatever is exact specification of their machines, it is not enough to handle that many numbers. But then the solution is just not to remember all the numbers. Let's hack this a little bit, and it isn't correct to just remember first 1 million numbers, because maybe first numbers on our path, they do not belong to a cycle. It's better to say that if a number is in some reasonable interval, let's say from 0 to 10 to 9, make it a Boolean array to save some space, or even better, in C++ it will be better for memory if you use bit set or vector of bools instead of Boolean array. So then this thing will take just 128 megabytes, so you can go much higher than that. So only if number is in this interval, then store it. So then mark it as visited. Then as you go, just see when for the first time you enter the same number smaller than 1 billion again. It is some heuristics. Maybe it does not work because From some moment you will only visit numbers bigger than 1 billion. Maybe this cycle is very short and it only contains numbers greater than 1 billion. Then this idea would be incorrect. But you don't even risk 20 minutes. You can just check that on your computer and see if the program will terminate in 15 minutes or maybe even in 1 hour. It is not stupid for such a problem to type something, run it, and then focus on other problems. Do not wait for that. It can run in background, and maybe it will finish in 15 minutes. And what turns out, if you implement something like this in this problem, is that this cycle is not that far away. It is enough to consider first around 1 billion numbers. This is like length of the cycle. I will check this number for you in a moment to confirm that, to give you the exact value. And this is not something that you would figure out yourself. It depends on exact numbers given in this pseudo random number generator. But given this short thing, it means it will be computed, by the way, in a few seconds, maybe 20 seconds. It depends on exact speed of the machine. But it is still not enough to just submit and get accepted. Time limit and this exact length of the cycle does not allow that. You can now think for a moment how to slightly speed this up. Just going away from this problem for a moment, let's solve this similar problem. Let's say given n, you want to find what is n factorial modulo some prime number p. And n is up to 1 billion. This is number big enough that O of n, just iterating over numbers and computing the product, is not enough. But here the intended solution is quite strange, and it is the following. Run your program once on your computer, and every some number of steps, let's say that every b steps, and b is, let's say 1 billion, every b steps, remember the factorial already computed. So you will know b factorial, 2b factorial, 3b factorial, and so on. 1000 numbers. The number of numbers you need to save is n over b. Each of those values, let's say that this value is 5125517, whatever. You paste this into your code. There will be a long array of preprocessed values. You also paste this one and so on. It's good to print them with commas. Like they should be separated with commas, or maybe even just with spaces and paste it as a string. Your code will grow big, but the limit for source code in this context is 256 kilobytes. This is 256,000 characters. If each of those takes around 10 digits or 10 characters, so this is 10 bytes. So 1000 numbers takes 10 kilobytes. This is maybe B was a confusing and bad name. By B I meant the step, and here I mean kilobytes, and bytes. So this 1000 times this is 10 kilobytes, so this will be size of your source code, still much smaller than this value. Some people don't like this method. It is kind of cheating because your program, does it really compute n factorial fast? Well, kind of it does. Because what we do then, of course, is once you're asked about some big number, let's say n is 5, 6, 7, 1, 2, 3, 5, 5, 5, and you need to compute n factorial, because you computed factorial of every millionth number, in particular you computed factorial of this one. You know this value. This is already preprocessed and you have that in your code, so also in your memory. This will be some array. And then from that, you just need to multiply it by next 123,000 numbers. The complexity, once you have this array already, and this is time to pre-compute the array on your computer, and the time of your submission, once you have the array, is this. This is small enough. This is exactly how we should solve our problem H. This path and cycle are slightly too long. What you should do is remember some values, and this way make the complexity from O of x, where x is length of this thing, down to O of x divided by the number of things you remember, by some number b. And this is the intended solution. I just checked the numbers in the official presentation of solutions, and here it just turns out that the start of this cycle is at step 350 times million, around that, of course, and then the period, the length of the cycle is what? It is around 182 millions. And if you divide this complexity by 1000, you have a fast solution. Factorial is a good example of that because it's very hard to compute factorial faster. Well, something like a power of a number, it can be done with fast exponentation in logarithmic complexity. But there are some things that you cannot speed up for more complicated functions, and this is, by the way, one of them. This is not a function that you can just transform in order to faster move between numbers. This is the idea of all the pseudo-random number generators. Almost 75 minutes passed. This is 1/4 of a contest. Teams working strong on various problems. For everybody but the few top teams, it's quite easy to know which problems they should now solve, because they should follow the leaderboard to see which problems are easy. It is much more interesting for the winning team or just the few teams in the top, especially if they have the overset of all other teams. It's an interesting situation when all the problems solved by anybody, you also solve them. Then among remaining maybe 6 problems, you need to decide on which problem you want to work. And it might hurt a lot because you might choose by mistake or coincidence an almost unsolvable problem, maybe the hardest problem in the contest. It's not that you will get more points if you solve it. Every problem is worth just 1 point. At the end, teams are sorted by the number of problems they solved. So it's much better to solve a medium problem. An important contest isn't something where you should try to find a cool problem that will entertain you, because this is often the case. Some problem might look ugly, like just a chore where you see what to implement roughly, you know you will make some mistakes, but you get the idea, and there will be also some interesting puzzle. You could imagine the same in math, also maybe in a math competition. There will be some areas, some topics that you like, some you dislike, but in such a competition you should sort by difficulty. This is the order of solving problems, optimal for your team performance. By the way, because it's a team, you should also smartly split problems between you. At the very beginning, maybe it's more chaotic and easy problems, everybody in a team will likely be able to solve them. But once medium and hard problems start, it might be a good idea to sometimes swap problems. If you read the problem and realize that even though the statement was about some animals, it is a graph problem, maybe give this problem away to your friend who is better in graphs, in graph theory. If you're the one studying math in university, not programming, then you should take every problem looking like number theory or geometry. Maybe there will be something involving formulas, calculus. Not often happens, but those problems that you should solve, so maybe 3 easiest problems among remaining ones, it would be best to assign them between you according to the topics. And there are different strategies for that. Some teams at the very beginning, one person would split the whole problem set of, for example, 12 problems into 3 piles according to topics. You can take a look at the statement and guess, oh, well, this one has polygons, so this is some geometry. I will give this to my colleague who is better in math. Here I see some graph. Here in the input, I see just n and n numbers. There are some queries. In the statement, I quickly saw that there are some queries on interval, on ranges. Well, I am best in data structures, then I will take it. So some teams do that. One person would spend the first 3 minutes of the contest guessing the topic of every problem and splitting them into 3 piles. Obviously, the other 2 team members, they can just, once they get their first problem, they should just read it, not read everything else. It is for sure not optimal for everyone to read everything in the first minute or in first 5 minutes. There's no reason for that. Most of problems, maybe not hard problems, will be read only by one person in a team. This is enough. Maybe if that person struggles at some moment of a contest, they can ask a friend for help, use them as a rubber duck. There is a method of debugging where you explain a solution out loud, and that might help. We indeed see here Uniboys in the leaderboard close to the top because they solved A long time ago. Every star next to a plus means the first accepted submission for this problem. We see UPC having already 2 such first accepted submissions. Uniboys with 1 for A, and Technion Rubber Duck with C. Then B is apparently somewhere more to the bottom. We also have Unifrenes, if I'm not mistaken, with problem I. There is submission for H, and it is accepted by team Unimi Lastatail Blue. This is the one we've just talked about, with some path, a cycle, and pre-processing values and pasting them into the into your code. This very nice code you currently see on the screen is that first correct submission for H. Indeed, here we see some values, a lot of values pasted. This image is only cropped to the left. Those lines are very long. So those usually you would see more these things in more human readable format. There are different ways to represent numbers for a machine. And here we see some 16-bit numbers, we see some 64-bit numbers, so longs. If you just represent them with digits, you would get on average 9 digits per number. Here, if I understand correctly, this is how is it called, hexadecimal system with 16 possible values of every character. Then it's slightly shorter. If there are 2 to 4 possibilities for a character and we want to represent a number of value up to 2 to 64, then it will be 16 instead of 18. Here values are, I think, slightly shorter than that. And a number we see here, n greater than or equal than this value right here. My guess is that it's either the cycle size or this initial path size plus this cycle. I think I talked about some number of this magnitude. This doesn't really match my notes, but the idea is for sure the same. You get some pre-processing, and thanks to that you have better complexity. They use a lot of shifting by 16 bits, so this means n shifted by 16 bits, it is the same as dividing n by 2 to 16 with floor for non-negative numbers, and this is around 64,000. So this might mean that they divided their complexity by this. Instead of just 1,000. Whatever you need to fit the running time. Sometimes it's good to just choose some convenient number like 1,000 or a power of 2. 16 is a nice number because an int is split into 2 groups of 16 bits. or long is 4. So maybe it's actually easier to operate with that rather than with 1000, especially because the modulo used in a problem is 2 to 40, so it is also a power of 2. That was one beautiful code. It might happen that some team will find a solution not expected by organizers, even in this problem. A lot of people for sure will not think about this pre-processing, and they will try to analyze the function, and almost always the solution that organizers thought about, it's the only reasonable solution you can think of in several hours. But with 100 teams, from time to time, somebody will have another idea that does work. So maybe we will see for problem H some different kind of solution, but likely we will not, just because also organizers had a lot of time to think about everything, think about possible solutions for every problem. It's not just one person who would write the statement, some solution, and say, yeah, that's done. Organizers are often former participants and or professors in computer science universities, classes, schools. Let's start, as the chat asks for, let's start showing some teams. We are on YouTube and Twitch. If you want to see some particular team, you can tell us. And we will do that in a moment. As for a suggestion, we are looking at a tunnel from Zurich, implementing KCPP in some small window. I don't think they like to use their whole screen. Maybe they're ready to implement 4 things at the same time in different corners of the screen. On the right, you see their list of last submissions for every problem they attempted. Currently, wrong answer for J. In kind of a background in Visual Studio Code, at the bottom you see a terminal, and there a command to compile program and then pass input to executable file. So some testing being done. Because there are 3 people in a team, like you would often see several codes being open, like here K, and in the background there is J. There was also a tab for f.cpp, that one is already solved. From time to time it's good to just close all the tabs, maybe not remove the files, because something might be useful. It can happen that 2 problems require segment trees, or 2 problems require doing something special with string objects, where you already implemented some function once, and if that worked previously, then just copy it. It isn't usually a case. Organizers try to create a diverse problem set, So for a perfect problem set, I would say that it's okay to remove all the previous codes. You will not reuse anything. It's especially bad, maybe, or funny in short contests like top coder or code forces rounds. If like 2 of 3 or 5 problems, they share the same part of a solution. There was a question, why am I speaking and not doing a contest? Well, I'm not a participant, I'm not a student anymore. And I was part of Central European Regional Contest, CERT, closer to Poland. There are different restrictions, there are various restrictions for ICPC. You cannot be too old, you cannot participate too many times, you cannot study for too many semesters. Actually, there is some tree, could be just a list of conditions, but there is a tree that says if you're eligible for participation. If you studied more than 4 years, then you need to seek some special, I think, approval from somebody important, stuff like that. But usually it's like if you are 26 or older, you're out. Maybe not this or older. If you are born in this year or earlier, you're out. Is there a live mirror to the contest? Yes, there is. All the links are scrolling through at the bottom of the screen. Let's also show UPC1. Universitat Politècnica de Catalonia. You will often hear me pronouncing some name more in Polish than here in some local language. Implementing here problem A, solved a long time ago by Uniboys. Counting from 0, A was supposed to be 4th easiest problem. So 4 is the number of problems easier than A. We will take a look at it soon. The cycle and path problem, H, was supposed to be one of the few hardest. There are some ties here on our list of expected difficulty, but H, we expected H to be one of 3 hardest problems. It isn't bad at all if organizers misjudge the difficulty of some problem, because still there are other problems, and it is not guaranteed that problems are sorted in any way. This expected difficulty is something we know here, but participants do not. They just see the leaderboard and try to follow that. The bad thing is when there is a huge gap. For example, there are 5 problems, half of the teams solve that, and then for 1 hour nobody solves any other problem. This means there was a gap of difficulty. Perfect contest consists of easy, medium, and hard problems. Actually, it's not like that trivial. It's a linear scale of difficulty, and there should be just no gap. If there are a lot of strong teams, and this often happens in the world finals, after like 1 hour of the contest, you will see the top team with 3 problems, but already 7 different problems were solved by somebody. That's because for a lot of problems, the solution isn't that overwhelming or complicated, requiring 2 hours of implementation. And if you get lucky in coming up with a solution and you read this early, you will get this accepted in 1 hour. When there are several problems solved and then nothing else, it's a skill to find the next easiest problem, but it's also some kind of lottery. Maybe you will be lucky there, maybe not. A reminder is that you can see PDFs with statements in the mirror contest. If you see on the bottom, from time to time there are links. Also, there's Codeforces blog with all the links. You can go to codeforces.com and see that in recent actions. Then you can go there and open any problem you want. Let's see the screens of top 10 teams in the order. And we will be back with commentary again in around 10 minutes. In particular, we will talk about problem A and its solution. A is called environment-friendly travel. See you in 10 minutes. Already a few teams getting accepted on K, A and J, single correct submission for H, and some incorrect ones. In a moment we'll discuss problem A, environment-friendly travel, the one about distances on the two-dimensional plane. Let's also remember there is a mirror contest where you can participate. It's of course good to think about it before the contest and organize a team. Teams there, they face the same set of problems. They have it a bit easier because, well, we cannot really restrict their number of computers. If they want to practice in a true way, they will have just one computer, but nobody checks that. Let's see the leaderboard of that mirror contest. With top teams there having 7 problems each. And here's the leaderboard with 3 teams in the top. Hoshirun, Kouchev is better than EdCoder, and ETH Real Rethinking, Ethereal Rethinking from Zurich. A lot of people solved here problem K. Oh, we are missing one column. Here we go. Column L. Kouchev is better than EdCoder, already solved L after 1 hour and 16 minutes. I would maybe expect more teams there to solve H already. We have a correct submission for D from Ravbil. But yeah, obviously, easiest problems will look the same here and there. If something is solvable in a few minutes, somebody will solve it quickly. But there is also a thing about following best teams. And it happened in one programming camp. First it took place, I think, in China, I don't know which city, and then in Petrozavodsk, Russia. And there was a problem with really long statement describing some card game. I think the game was called Joker, but I'm not sure about it. And it was very long, complicated. There was a series of rules, and you needed to figure out something, maybe what should be your next move, or maybe which player has the winning strategy. I don't remember the details. The thing is, in one of those 2 programming camps, I think the Russian one, somebody solved it quickly and then a lot of people followed. The solution turned out to be to check if there are at least 2 jokers in the given deck of cards. And in that case, these complicated rules would imply that, let's say, the first person is winning, because always there is some quite simple strategy. But it was so hard to get through this statement, and it could as well be a very hard problem, that well, in this camp it was one of easiest problems. It turned out to be one of easiest problems and almost all teams solved it. In the other camp, nobody solved it during the 5 hours. So following the leaderboard is a thing, and if sometimes all but one problems are solved in 4 hours by several teams, and then for sure everybody will try that last problem. Otherwise, you don't have any guarantee that some strong teams try a problem. If something doesn't look easy, is very long and nobody solved it, why would you choose that over some other problem that looks more promising? So this was leaderboard for the mirror contest. Link to that is at the bottom. And now we will talk about problem A. Problem A, environment-friendly travel. There are some points on the plane. There is source and destination. And easy problem would be to find the shortest path between source and destination. And well, that shortest path would be to go directly between them. Now we say that the distance between 2 points isn't just Euclidean distance, it's just slightly more complicated to get integer numbers. It is floor of the Euclidean distance, so floor of square root of delta x square plus delta y square. Not floor, the ceiling, sorry. And here, is it still true that it's good to directly go between S and T? Yes, because for sure we will not get answer better than that. Maybe it is not trivial, but it is also not important. By the way, the constraints are quite small with n and then the number of other stuff. In a moment I will explain that. Some values are up to 1000, some values are up to 100. Let's not focus on that. But what is important? For some pairs, there are also other ways to travel between them other than a car, and each of them has some CO2 cost, or maybe a multiplier. Like here maybe it will be 3, here 17, and here a 1. Different ways to travel around. They produce more or less pollution. And now the goal is quite complicated. You need to find some path between source and destination which satisfies the following condition. The total distance so the sum of Euclidean standard distance between A and B, two consecutive vertices, points on this path, the sum should be smaller or equal B. And given this condition, you need to minimize the total CO2 cost. So minimize the sum of CO2 used. And if there is some path like this one with the cost of 3, you say that 3 times the standard distance between A and B is the CO2 cost. And you minimize the sum of that. Given this first requirement, that this first one doesn't use CO2. This one is just about time to travel. So the total distance of your path, the total length of your path. And given this condition, you need to minimize the sum of CO2 used. And it is not correct to just say we should find the shortest path. It also is not correct to say that we should just minimize this and then check if the first condition is true. Because maybe there is some way to minimize CO2 like this one. Between C from S, maybe we should travel this way. Here there is multiplier 1, here there is again multiplier 1, or maybe even more complicated. Here a 1, here a 1, And this would be a path consisting of those ones with smallest CO2, but maybe it does not satisfy the first condition, the one about the total distance small or equal b. Maybe we need to make a shortcut here with bigger multiplier, like a 4, but thanks to this we satisfy the first condition. So you need to do that. Of course, you cannot consider all the paths in the graph because there is an exponential number of them. Because to find the shortest path, you would just use Dijkstra. Here, we also should try to use some modified version of Dijkstra. So maybe for every vertex, we should figure out with what distance we can get there and what CO2 usage we can get there. And it is not enough to just consider all those pairs. So maybe here for every vertex, I would have pairs like 5 and 20. It would mean I can get here after 5 seconds. Like this is that distance that should be up to b in total. Then there is also 7 and maybe 23. And now the first observation is that, well, this is stupid. If I can get after 5 seconds with CO2 usage of 20, then this thing is only worse. So maybe here 7 and it will be 50. So I can spend more time to get to this vertex, but I will use less pollution, less CO2. Maybe this is some idea. And because numbers here are integers and and the number of those connections given, like the number of edges with some CO2 multiplier is not that big, what we can do is implement this very much modified Dijkstra, where for every vertex, for every time to get there, we will just remember the best CO2, minimum possible CO2 to get there. And if you also add some simple, you might need to avoid time limit exceeded, add some simple stuff like do not consider things where this already exceeds b. So this must be small or equal b, otherwise you will not finish at all. And with such simple tricks, you will get accepted with some polynomial complexity, also depending on the size of this grid. Do we have some limits for coordinates? Yes, all coordinates are up to 100. And this is important thing here. xi, yi are both up to 100 and integers. Also, it is important that the formula for distance is integer. Otherwise, the number of possible distances would grow, I'm not sure if exponentially, but for sure a lot. We would have some rational numbers there. Here with numbers up to 100, the single distance will only be up to 100 times square root, because given those conditions, if you make a drawing, between 0.00 and 100, this distance will be 100 times square root of 2. Rounded up, you will get around, 142. So this will be direct distance. It might be better to make some path. Every vertex you will visit once, at most once, so you already have some strict limit for the total distance of n times this 100 times square root of 2. But it's for sure much better. It is stupid to go like that all the time. Or maybe not. If the number of edges allow that with proper CO2 multipliers, then it might be possible. So yes, I will say that this distance should be up to this value, but there is also a limit for b anyway, so we do not have to consider that. Actually, forget about this. And it is just true that b is up to 100. So without that, the complexity would be worse. But b will be in the complexity, and for every vertex, you can store up to b values. You can think about it, well, this is Dijkstra, but you can think about it as dp of vertex and distance from 0 to b. And for this pair, what is the best CO2, minimum possible CO2 used already to get to the state after this distance. You can also treat this d as time to get here. Some time ago there was a comment, can you talk louder please? So the question for others, please, if you think indeed the stream should be louder, say that in the comments and we'll make it slightly louder. Yeah, this was problem A. Let's get back to watching the participants. This is already time when even strong teams should sometimes cooperate a little bit. Well, not between different teams. Within a team, 2 or 3 members sometimes should talk about the same problem. Problems aren't anymore about just implementing one line and that's it. They are about thinking about a solution, about the complexity. Because you need longer code, so also there will be more mistakes. Submissions are much less frequent right now. We see here what J with runtime error. Every time in ICPC you submit a problem, and it's also the same for a lot of competitions in programming, in competitive programming, you will see just a verdict, either accepted, and then you're done, forget about this problem, or wrong answer, so you printed something incorrectly, your answer is not correct. Runtime error, something was bad during the run of your program. For example, you divided by 0. Maybe you tried to access index -1 in your array. There can also be time limit exceeded. Your program was too slow. There is time limit for every problem. Like in A, we talked about a moment ago, it was 3 seconds. Time limit is provided in the statement, and so is memory limit. If you use too much memory, you will get memory limit exceeded. In some contests, it is runtime error as well, because well, you might say that if you add something to memory, you will eventually get an error for that. And in some judges, it is treated as runtime error instead of memory limit exceeded. There is also compilation error, and this one doesn't give you 20-minute penalty, and can be caused by a mistake, like submitting wrong code or like wrong file. Instead of .cpp, you might by mistake submit your input file if you save that as, let's say, in.txt. There's also rule violation verdict if you try to do something fishy, like open file, print what is in your directory, fork, so try to use multi-thread processing, or do something in parallel. These are all forbidden, and if organizers think you had malicious intent, you will be disqualified. Sometimes it is a mistake. You might do something like, it's hard for me right now to think about an example, but if you submit by mistake instead of the main code.cpp, you will, let's say, submit some generator of input for your code, but this one uses something forbidden to submit for, but use that on your machine, maybe you will not be disqualified. I'm just guessing here. I'm not the one making decisions. But mistakes happen, and they can get disqualified. But for sure, if you had any malicious intent to disrupt the contest, then it's quite sure what will happen. There are also some things that slightly disturb the contest, but not so much, like printing a lot. If your code, let's say in problem H, If your code has thousands of characters, then better not to print that. Maybe it will take 10 pages, then it's okay. But if it takes 100 pages, organizers should be prepared for that and limit their source code for printing a little bit. But you don't want to waste 100 pages, you will not read that anyway. Likely you wanted to just print your code, not the pre-processed arrays. So just copy whatever you want to print to another file and then print that other file. Two hours passed. This contest lasts for 5 hours. In some time we will get some of the main judges here to comment a bit, to see how the contest doesn't go the way they expected, maybe for some problems, or maybe it does exactly as they thought they would be. I think H was supposed to be a quite hard problem. It was already solved by, I think, more than one team. Can we see the leaderboard, please? Again, a reminder, we read your comments in YouTube and Twitch. If you have some suggestions, later if you want to see screens of some teams. H was solved by 2 teams, so not so many. A and J already getting some healthy number of submissions. It is unusual what happens in the top, that J was solved by prefix of teams. Some number of teams at the very top, they solved problem J, but for problem A, the number of accepteds is similar, but it's not just prefix. So like teams number 1, 4, and so on. Will you try to solve the problems later on Codeforces? Well, we are describing some solutions now, and problems are available in the mirror contest. In the mirror contest, by the way, team Hoshirun already has 9 problems. In particular, they have D and G, already, yet without H. So I expect them to solve H quite soon. It's not a hard problem. Here we have some teams having solved that already. Then they will have, right now they miss last 3 problems, E, H, L. Then there is CodeChef Better Than Edcoder with 8 problems, 4 problems to go. Top 10 teams now, starting with EP Chopper. I think it's L.cpp. You saw them typing second player will win. It's quite dangerous to type that yourself. You might get an ugly typo, and then you will not find a mistake for a long time. Many participants dislike this thing of not just printing 1 or 2, like a number, but printing some long sentence. Instead of none, then maybe organizers would require you to say, there is no solution to this test, and you need to retype that. It's better to then just copy it from the statement. Problem MEF from Zurich with wrong answer on A, and right now typing something for that problem A. École Normale Supérieure de Paris with 6 problems. Already solved problem H. Now we see some printout for A. When you see time limit exceeded in the list of recent submissions for A, well, it should be quite common. There you need to use a couple of tricks, like only only considering distances up to b, and really using this Dijkstra where you don't consider unnecessary states. Wrong answer is also perfectly possible. And you need to be careful about rounding. The real values operations are always dangerous. In this problem, it shouldn't be a big deal with coordinates up to 100. For bigger ones, it would be. Computing square root of the sum of two squares might get imprecise, then you must be careful with rounding. Here we see what floor of square root of power, this double comma 2, and so on. It's safer, instead of power function in C++, to type a times a, instead of typing power of a comma 2. For square root, well, square root is fine, but then you shouldn't use function round. You shouldn't round to nearest integer. You should use the ceiling. Computing, by the way, square root of some real value, well, computing square root of an integer and then computing the ceiling of that can be done with integers. When you compute, say, square root of 100, and by mistake you get 9 instead of 10, you can on integers fix that. You get some value x, and then you check if x squared was that value from which you computed square root. If no, you can increase x by 1 or decrease by 1 accordingly. It is a very common and confusing mistake in competitive programming. A lot of people struggle with that at some point. And it might be one most common mistake, not to do something correctly for real values and rounding. In C++, the second most common mistake would be not to create a good custom comparator for a sort. If you want to sort some objects by, let's say, you sort points, x, y, by coordinate y first, there is a way to create a custom comparator where you will say that you compare by y. But a lot of people there type something like y smaller equal second y. Instead, you should say smaller, not smaller than. And it is undefined behavior and can cause runtime error. But a very strange one, where everything works in your computer and not in the system judge. You don't want to get, you don't want to have any undefined behavior in your code, because this one is almost something like this might be impossible to figure out on your computer. You will have a test where it works on your computer, so you will think everything is okay, but it doesn't work on the judge. This is what undefined behavior does. And in the real world, in your job, you also need to be careful for that. This is the case where customer can call you and say something doesn't work, and you will answer, you will reply with, "It works for me."
Submission on L success. That's the talk.
Submission for L. Cool. Let's see EP Chopper then. A cool information is that L was supposed to be the hardest problem of the contest. We don't see here.
Yes, I see the scoreboard and CDS as well.
So sometimes our list of submissions lags a bit, and now on the right you don't see L with accepted verdict, but we see on their screen they submitted L and got correct. You will also see here some clarifications because there were typos in sample explanation of L. L is a problem about some game on a grid. And well, what do you do for a game? You compute Grandi numbers, and that problem is about that, where you need to implement quite a lot, got everything right, no mistakes, and then you will get accepted. it wasn't very surprising to see not so slow accept for L in the mirror contest, because if you are very good and already solved tens of problems similar to this one, it's very standard, but also very hard if you aren't familiar with Grandi numbers and game theory. We see here EP Chopper working on problem G, also one of hardest problems, but well, they already have quite some. We see here the late verdict for L accepted with first correct submission for this problem in the contest. Now they have 8 problems, 4 to go. In a moment we'll take a look at their code for L. So here's most of the code for problem L by EP Chopper. We can analyze some of this. But yeah, for hard problems, it isn't surprising that it doesn't fully fit on the screen. There was some grit in the problem. We will not analyze the full thing. Again, you can see the PDF statement in the mirror contest. Link is at the bottom from time to time. But some things that we see here are directions to walk through a grid, a lot of arrays, in particular with functions for visited, likely for some DFS in a grid, function for being inside a grid, n by n, one kind of DFS, here's some other kind of DFS, then some nim function related to game theory. Here you see the important part. Once you see that you can get to some states, similar to one very simple problem today, you need to find the first number not present in that set. So like in our first problem today, I think it was I, for a set 0, 1, 5, and 4, we should say 2, because number 2 is the smallest number not occurring here. This is what this part does. But of course, this is the hard part, to actually implement transitions in the game. And yeah, you need to know some theorem, you need to be able to apply it, and you need to code quite a lot of code. This might be more than an average senior programmer implements during like a day in the company. The better and more experienced you are, the less you actually implement. It's more about code review, thinking about something, making decisions, and not about implementing Dijkstra. But it's good to start with understanding of basics and knowing algorithms. And well, right now, competitive programming might be a good thing to do while you study, because algorithms are very important for coding interviews. This is what companies check when you want to get a job. So maybe you will not be asked this question in a coding interview, but something more similar, something simpler. But why would they check if you know game theory, like Grandi numbers or numbers? For contests like this one, it would be very hard though to just give problems not requiring any knowledge. Those are too easy for people who solve hundreds of problems. Some of them maybe already solved more than 1,000 problems like this one, not exactly like this one. And then you need quite a hard problem to challenge them, to give them something to do for 5 hours. And it can happen that somebody will solve everything in 3 hours or 2 hours. Here we already see that it will not happen. It is still possible that somebody will solve everything. I don't think there is a single impossible to solve problem here. Sometimes there is. Sometimes there is a problem that judges are sure nobody will solve that, and it's only to entertain the strongest team. Here we might see a fight for the whole problem set. Just remember that you can see the full scoreboard by following the links at the bottom. Here's the leaderboard, the current leaderboard, with EP Chopper on the top, then UPC1 and ETH. We will go through the screens. You can request something now. If you want to see a screen of your favorite team, just say in the comments. We are on YouTube and Twitch. By the way, whenever the camera points at somebody, you can count their number of balloons. And here, because we see somebody with 8 balloons, you can get which team it is. Actually, you cannot anymore because there are 2 teams now with 8 problems.
it was EP chopper in the first place.
Okay. There was a question about problem K. Can you explain K idea, please? Not for now. For security reasons, stuff like that. We in the commentary team, we did not have access to problems in advance, like yesterday or a few days before. And well, it's a good choice to just limit the number of possibilities that something will go wrong. I will maybe talk about that more in a moment. And because of that, just before the contest, we had time to read more about some problems and hear more about them, discuss with main judges. But for example, I don't know problem K yet. Maybe we will get somebody else to explain it, or maybe I will get familiar with it closer to the end of the contest. So for now, K remains a mystery also to me. Then I only know the name, which is, I think, bird watching. Okay. Show us first placed EP chopper. Yes, in a moment we'll get their screen. If possible, also camera on them, but it is not that trivial for us. Uniboys right now, their screen. Remember that they solved problem A quite fast. Because of that, they have nice time with 5 problems. In C++, if you get a lot of warnings because of comparison between different types, it's for a reason. You should avoid that. There is a compilation flag that silences such warnings, but it's better to always cast size into int from unsigned int. There are very tricky mistakes there. Here, Politecnico di Milano with 5 problems, now working on Untitled. What do we see here? 0, -1. Some adjacency graph. 13th place, UM greedy to bronze. Implementing problem A. Already created some graph, but nothing more. 14th place, ENS culminate. Well, when we right now see the screen with the leaderboard, doesn't mean they look at that. It means they open that. And likely all 3 team members, they work on some problems, maybe a single problem if they just do that together. Here, problem A being judged, pending, and accepted, but we don't see that yet on their screen. Maybe because it was a shift of a screen. If you remind me in the chat which team it was, we will get back to the screen. But now we will get to EP Chopper, and they just submitted G. This is their 9th problem. Here's a screen. They immediately start at H. Once there is some accepted, person who has just implemented that usually like runs away from the computer, not runs, but makes it available, and then immediately the next person sits there. It's good to just quickly, make a cheer out of that, some high fives, and then get back to work. Some teams like to get rid of all the paper related to solved problem. So you might see from time to time somebody tearing a piece of paper, or just putting them, after crossing it out, putting them below the desk. It helps in keeping everything clean on the desk and just having the stuff that you work on. And it is good if there is one person, you can call them a team captain. There should be one person responsible for monitoring the leaderboard, and from time to time checking with other with teammates what they do right now. Nobody should be stuck for 2 hours on a single problem. Maybe they just understood something wrong in the statement, for example, and they shouldn't be stuck for next 2 hours. They should just swap problems with somebody else or talk with somebody else.
When you do submissions in Czech.
So UPC1, let's see their screen and status. Also solved G, they were the first to do so. I guess this is Vim, and then it's harder to see the code name, but we see characters CBLPRS. So this is likely one of those problems I do not know. And if you wonder, there is some small delay between the stream and when you see it, like half a minute. So it isn't that trivial. When you type something in the comment, for example, saying that this is bad right now, do that, we see that with some delay. So problem D, gnal cuts. I'm not sure about the pronunciation. We will talk about it in a moment. It is about some complicated structure, graph-like structure, where there can be a lot of operations. Each of them is described in the statement. D does something, then S, P, C, R, P, S, D, U. There are repetitions, so this is just an example, fortunately. 7 different bases, C, D, L, P, R, S, U. Each of them does something else. Nobody likes those problems, to be honest, but you want to have some diversity. Some problems will be, as I said earlier, a chore. What is the length of the contest session? It's 5 hours. It's always 5 hours, 3 team members, and around 10, 12 problems to solve. In what building they are doing tasks? Well, we are on the south of Paris, in Telecom building. It's always some university. Maybe for World Finals it's harder to find a venue. For regionals, it is usually a university. For World Finals, they need to get some bigger hall, a huge tent or whatever. Sometimes those are halls where some sport events happen. Then there can also be some audience sitting and cheering for their teams, but they need to do that quietly for most of the time. And am I at home? Yeah, no, I am not. I'm here at the contest venue. There's a small room, like a classroom here, where we have a bunch of monitors, a microphone, and a team to monitor everything stream-wise. There is another room where judges are, and they handle more important stuff. Like here, everything in the stream is optional, you know. If everything broke, still the contest wouldn't be cancelled because it's only a stream. But judges during a contest, they should monitor the submission queue and see if like nobody gets wrong answer with correct submission or accepted with incorrect one. They should at least investigate that in that case. It is often too late to correct something, but maybe one thing where they should intervene is when a lot of teams get wrong answer for the same reason in some problem. And it is not the mistake of teams, but just something is not clear in the statement. Maybe for judges it was clear that there, for example, points, that in some problem maybe there is a bunch of points given, and nothing forbids those points to be at the same position. And if this is clear from the statement, it's all fine. But maybe there was some mistake, or maybe not a mistake, but something at least confusing in the statement, suggesting that those points are in different positions. And then teams assumed that, but it wasn't really guaranteed. It's just a small example that came to my head, but I'm sure you can imagine more such things. And then from time to time there will be public announcement from the judges. Please note that, or here there was a mistake. This, as I said, sample explanation maybe should say something different. This is why they monitor the contest, and if there is any issue, it's better to respond to that immediately. How many teams will go to the World Finals? It's a very good question. The number of, so I mentioned earlier the structure of ICPC with some regionals, then World Finals. One more very important condition is that there must be at most one team from every university. It's hard to get to finals from some strongest universities in the world, like MIT, or well, actually strongest in competitive programming are usually Russian teams. So as if you take strong Moscow or St. Petersburg school, it is very hard to get to the finals from there because only one team of 3 people will advance. But from regionals, from 2 to 15 teams go to the finals, depends on the size of region and their strength. From Swords it will be around 4 or 5 teams. For example, for Central European regional contest, where like Poland, Czechia and Slovakia are, for example, also Croatia and some other countries. Usually it's around 3 or 4, but it's a smaller region. The performance of that region in the finals might affect the number of slots in the next year. If those teams get a lot of medals, then there might be one more position, one more slot in the next year. So you should cheer for teams from your region if you want to participate in the next year. Sometimes they say a formula is like, for this region it is 2 plus the number of medals from previous year. But it isn't that public or official, and it's more like we will see how many teams we want to handle, we will handle how results look like in every region. Of course, this leads to some teams being dissatisfied and saying that it's unfair, but this is how it goes. This is usually reasonable. It isn't that stupid to say that, oh, here second and third team were very close to each other. There was only like 10 minutes difference, so maybe we should take all top 3 instead of top 2. if we look right now at the time penalty, EP Chopper has 641 minutes, then UPC 568. Now if UPC solves one more problem, it's now 2 hours and 40 minutes. This means 160 minutes from the start. So they will be at above 700 minutes anyway. So for UPC, one problem is not enough to get to the first place. We can analyze that calmly and just calculate that. But for teams, sometimes it is an important decision when to submit. When you have a ready code, you might say that it's good to just submit that. Oh, we have a submission from Zurich for problem D. It's being judged. The bar moves very slowly. Apparently there are a lot of tests, or just the submission is quite slow. 1/4 done, I think. And with what we computed a moment ago, 160 minutes, they will get around 400 something. They will be at third place. They will have better time penalty than EP Rouge. Roma 1 from 22nd to 19th place for accepted A. MEF Zurich still being judged. And yes, I think we will see them go up by 1 place. They have 2 incorrect attempts for A. If they fix that soon, again, they will not move up, but it's right now. But you must think about the end result. Yes, MEF Zurich solved problem D. They are the first team to do so. Indeed, MEF Zurich already opened problem A after getting D accepted. And they are implementing something here. We see a priority queue. Looks like they are creating some completely new part in their code. Here are top 10 teams and their screens. We will have now a 10-minute break from the commentary. Then maybe we'll get some judges to come here and also talk a bit about the problems and how the contest goes. Tune in for that in around 10 minutes. two teams already with 9 problems, EP Chopper and UPC1, all the time fighting for the top place. Likely we will see the fight between them for winning this contest. Then there is Zurich, MEF and EP Rouge with 7 problems each. But ENS also has a nice time, so can still, I think, get higher than them. And we'll see how it goes. There are 2 hours remaining. We now have with us Vincent, sorry about the mispronouncing, from Judges. Hi.
Hi.
What do you think about the leaderboard?
Well, I mean, basically, it's impressive that, some teams could solve already 9 problems in much less time than it took the judges to find or solve or whatever. And so, that's great. And then we hope that problems E and H, remain difficult but feasible for them. We'll see.
I think E wasn't supposed to be that hard.
Yes, E was supposed to be, not the nicest problem you want to rush on when you read the statement, but let's say it does not use clever ideas like the problems with river game, for instance.
Mm-hmm.
So,
okay, so yeah, EP Chopper, I think it has it quite nice after already solving L. That one requires a lot of time, I think, to implement.
Yes, solving the problem L is really a good achievement for them. And also problem J is quite hard as well, so it's very good.
Yeah. We will now talk about problem K, birds.
Mm-hmm.
Let's hide the leaderboard. And here we are with some examples. So Vincent, talk us through this example and what we need to do in this problem.
Okay.
This is K.
So here, this problem K is a graph problem. So actually, the problem statement is that you start from some graph G, okay, and it doesn't work.
Focus.
Okay, yeah.
Try down.
You start from some graph G, okay, and then what happens is that you will find some. What you have as an input is some graph G prime, okay, and so the point is that this graph G prime, it's a graph that contains all edges of G, but it does also contain some edges that are in the transitive closure of G, okay. So for instance, if in my graph G, I do have something like 0, 1, and then 2, okay, then actually there are 2 possible graph G prime. Either I have G prime is equal to G, okay, so this is case number 1. It's G is equal to G prime, okay? And the case number 2 is where, how do we change the colors?
Here. Yeah.
Okay, yeah. And another possibility is that we could add this red edge, okay? Yeah. So basically you already have all the edges in G, and you may add some edges in its transitive closure. Okay.
So for every pair of vertices AB, if you can get from A to B, then you can add an extra edge in G prime from A to B, but you don't have to.
Yes. Okay. And so obviously, so now given a graph G prime, the graph G you may have started from is not unique a priori. Okay. And so the problem here that we want to have is that we are given the graph G prime, and we want to have among those edges that come to some vertex, let's say 2, those edges that must have belonged to the original graph G. Okay. Mm-hmm. So basically, it's just we take the intersection of all possible graph G's that would have given the G prime we are given as an input of the problem. So, for instance, we can look at what happens on the actual graph that is given as an example here, saying that we are interested in those edges that would lead to the vertex 2 in all possible graphs G that gave this as G prime. Okay. So, basically, this vertex 5 cannot work because you don't have an edge from 5 to 2, okay? Mm-hmm. And as well, vertex number 3 doesn't work, and vertex number 2 doesn't work. Okay.
Can there be self loops, like an edge from vertex to itself?
I don't remember if from the problem statement it might, but this does not add anything to the difficulty of the problem itself. Yeah. So like if you have a self loop, just keep it and then you remove it for the sequel of the problem.
Mm-hmm. Okay.
And so now, for instance, if we look at a vertex 4, let's say, I mean, it's a good tentative. I mean, the edge from 4 to 2, it's a good tentative edge that would be in all original graphs G, okay? Mm-hmm. And in particular, this one, it must have been present in all original graphs G, okay? Because if you removed it, then you would have no way from 4 to go to 2, okay? So basically, the fact that here you do have some edge from 4 to 2, it means that you already had some path, okay, from 4 to 2, okay, maybe with some intermediate vertices, and now you see that you don't have any possible intermediate vertex, okay, and therefore, I mean, you know that this edge actually must have belonged to every original graph G you had. So this node number 4, it's okay, okay, and the same reasoning applies to the vertex number 1 here, because from 1, if you drop the edge from 1 to 2, then you cannot reach the vertex 2 in the end. So you must add this edge. Okay. But finally, for the 0, I mean, here, you could either go directly from 0 to 2 or go through 1. So this one, you don't keep it. Okay.
So the edge from 0 to 2 wasn't necessary in the original graph because maybe just, anyway, there was a path 0, 1, 2 in this order, and this is why edge 0, 2 was added later.
Exactly, yeah. So this edge was not necessary in the original graph, and therefore you don't keep it. Okay. So now, the problem is, so here on some example, we could do it with some kind of brute force or whatever, okay? But then we need to have some efficient way of computing those edges that lead to 2 and that were necessary in the original graph. Okay.
What is the magnitude of constraints? It's like 100,000 or 1,000?
The magnitude of constraints is basically, the size of your graph, it would be of the order of 100,000 or 1 million, something like this. So basically, you can't have any algorithm that would work in quadratic complexity. Okay. And so now, some naive approach would be that for, let's say, for the vertex 0 that we had here, okay, it doesn't work. Okay. So for the vertex 0 that we had, I mean, we could just drop the vertex, the edge from 0 to 2, and then do some path research to see whether you do have some path from 0 to 2 in that graph where you have subtracted some edge. Okay. And then you do it for every edge that you have from some node to the vertex 2. Okay. But this might take too much time. Okay. Because basically, 2, it can have up to 1 million predecessors. And then each search in some diminished graph would take a time approximately 1 million operations. And so it would be quadratic and it's too much. Okay.
I think we can work with this drawing.
Yeah, okay. So that's fine.
Click a color again.
Okay. So here, I mean, what I say is that if we just try to look at whether there is a path from 0 to 2 in this smaller graph, okay, we can do it. But it could take us some time, let's say 1 million, and we cannot repeat this 1 million times.
For sure, we cannot do that independently for every edge to consider if that was for sure necessary.
Exactly. So we need to find some other way, okay? And such another way is the following. It is actually what you should do is removing all the edges that lead to the vertex 2, okay? You wonder whether you can reach some other vertex that would have had such some edge that leads to 2. So let's say now I remove all the edges 0 to 2, 1 to 2, and 4 to 2, okay? And then if, for instance, from 1, I could go to the vertex 4 in that smaller graph, then certainly if I did have some path from 1 to 4, I would be able to finish that path by using the edge from 4 to 2. And so basically the edge from 1 to 2 would not be necessary.
Okay, so we find some connections between 0, 1, and 4, like some complicated paths.
Yeah, so if there is some path from 1 to 4, then we could complete it with the edge 4 to 2, and so the edge 1 to 2 is not necessary. Okay.
Yeah.
So what we just have to do is, in fact, so assuming that you have all dropped all the edges that lead to the vertex 2 and remembered which was the origins of these edges, okay? You take two such origins and you ask whether you have a path from one to another, okay? And in particular, I mean, something that's important is that as soon as you know that you have a path from 1 to 4, for instance, then actually the vertex number 1 is already, I mean, like, you won't keep the edge from 1 to 2 in your original graph, so somehow you would be able to kill that vertex number 1, okay? So in particular, what we would do in general is that, so you have your target node T, okay? And then, for instance, you have identified some node N, okay? And then with some edge from N to T that you have just dropped, okay? And now what you can do is that you find the entire set of all nodes in the tree, okay? In the reduced tree that can reach the node N itself, okay? And so it means that whenever you have some node here, okay, you would have some path that leads to the node N and then to the node T.
So
okay.
For a moment ago, N would be our 4 in the graph from
Yes.
example, right? And 1 was removed because
Yeah.
from that we
Yeah.
can reach 4.
So for instance here, N would be the 4, and now I would have the number 1 that I know that I have a path to 4, okay. And so in particular, I know that all these vertices I will see here, okay, besides N itself, okay, they are bad for my algorithm.
And I will not consider them
Yeah.
again in the future. Okay.
And then, so now, I mean, you can do it as well for, I mean, like starting from some other vertex N prime that is a predecessor of the T, okay? And so you can perform the same computations, for instance. But at some point, like, I mean, certainly those vertices that had a path to N prime, I mean, you do have some intersection with those vertices you had already seen before, okay?
Yep.
But, I mean, these, you don't need to treat them twice, because if they have already been discarded as being good predecessors of T, because they could lead to N, then as soon as you explore them when looking at those ancestors of N prime, you don't need to go further in your exploration because they are already bad.
Then we could hit quadratic time.
Yeah.
We didn't want to click that.
Okay. So basically, the point is that when you start exploring ancestor sets in your graph with a few edges that have been swapped, okay? And whenever two ancestor sets intersect each other, you have already explored the intersection once, so you don't need to explore it a second time. And so overall, I mean, all these explorations that you will run starting from the ancestors, the predecessors of T, I mean, they will run in a time that is proportional to the size of the graph, and so you can do it in the good complexity.
Okay, yeah. It will be just linear of number of vertices plus number of edges.
Exactly, yeah.
Standard DFS, well, multiple DFSs, but will not visit the same thing twice.
Exactly.
Cool.
Okay.
And I think this is all. Anything particular to watch out for here? I don't know.
No. So in practice, in the solutions we judges have reviewed, I mean, all the solutions that worked followed more or less, I mean, this version or a variant of it.
Okay.
So it was just you run DFS and you stop your exploration as soon as it becomes useless, and then it works in linear time.
Okay. I was earlier saying on the stream that graph problems, or maybe it was yesterday, I was saying that graph problems are very hard to prepare just because it's hard to generate graphs. Would you agree? Did you maybe have something to do with preparation of this problem?
Well, here...
If you want, I can answer because I made the test.
Okay.
Okay.
Maybe grab a chair.
So for yesterday there was another difficulties, which is it's hard to find counterexample for flows.
Yeah.
I mean, hard counterexample for flows. And we wanted our algorithm to pass even with a bad flow algorithm, but the right idea of reusing the flow.
Vincent.
For today, it's much easier because we just want that they don't explore many times the same nodes. So we wanted to create sets where if you don't have the right algorithm, you explore some nodes many times and a lot of nodes many times. So I think that the limits is Oh, I can draw the idea of the example.
Yes,
That's
I
what
think we can exactly now talk about how to create some tests for this problem.
The first idea that is pretty, that you can come is to use the idea that Vincent just explained of re-exploring everything and not considering the fact that you have already explored the intersection. But if you have, your node T here,
Try now.
Okay, if you have your node T here, and you have a lot of, node coming in, and then they all can go to each other. Oh, sorry, I'm moving outside. Okay, so this is not very clear, sorry. Can we scratch? Can you see what I'm...
I
so basically we are doing
so we have a bunch
a
like
wheel,
around
basically,
T?
yeah.
A
Basically we are creating a wheel. And in this case, almost all nodes are predecessor of T, but they are all reachable from each other. So if you run a DFS, a stupid DFS, then it will be bad.
So let's say that first we called that n previously. Then we will visit all of those once. But if you don't remember that those shouldn't be checked again, then for example for this n prime, you will again check everything and so on and so on.
So that's the first simple test case. But then you have some bad algorithm that will work fine on this graph.
Because maybe we care about those vertices from which there is no edge to T. Maybe there's here some part like that. Does it matter maybe?
No, it doesn't matter because you are actually considering only... So can you repeat?
Yeah, so I thought that maybe this test doesn't cover everything because all the vertices, they have a direct edge towards T. Maybe it matters to have some vertices outside, or maybe not.
Well, it depends on the algorithms that you want to discard. But if you want to discard the stupid algorithms that just compute all predecessors from a given node, then this is fine.
Yeah,
the
for
problem,
sure, I see solutions that will not work already for this wheel.
So one other idea that we have not explained is that instead of looking for predecessors, we might do the opposite, looking for people, for nodes. I am in the node n, and I want to know whether there is a node n prime that is reachable. And well, instead of computing predecessors, we can look for successors, the opposite way.
Won't it be the same thing for the wheel? Or no?
No, because you stop at the first node that you look at if you have a wheel. Because the first node you look at is correct.
For this n, because we see that we have here some other vertex with an edge to T, we already say stop.
Yes.
Okay.
So basically what you want to produce, because we are pretty large with the limit is 100,000. So we cannot do anything that is quadratic or even n 3/2.
Yeah, so n square root of n. Yeah, that also is okay.
That's too bad. So what we can do is actually have a square root number of predecessor of n.
Okay.
And each of them are looping have a long loop of predecessors. So I will try to draw.
Just look here to follow the cursor.
Okay. So we have
try
T.
to avoid this part.
Okay. We have T, and then basically what we'll do is we'll draw some kind of flowers, you know. So what I'm drawing here are not nodes, but long chains of nodes that go back to T. And
okay.
Sorry. And if we do something like this, so we have n square number of such small loops.
Square root of n.
Yeah, square root of n, and then each loop is the size square root of n.
Okay.
And in this case, if you run the predecessor algorithm, you will look for a long time. Sorry, no, okay, it's not. Can I erase something?
Yes, sure.
Okay, so sorry. I don't remember exactly what we did, but so basically the idea is to have something like this, but then at the end they are all going to each other.
Oh, I think that makes sense.
So we have several such cases.
I would say that it's a wheel, but kind of extended.
Yes, with a long,
yes.
how you say, thing in.
I know what you're talking
Yeah,
about.
okay. So basically we have long range and then they are talking to each other. And then if we don't do, so we have designed several algorithms and we designed several tests to make them fail because some of them are forward and some of them are backward and some of them are more clever than others. Like you might want to try to use something like bit set or everything, but then you have too many nodes. So even a bit set won't save you if you are quadratic.
Usually with bitset we get complexity like of something divided by 32. Like for example, maybe n times m divided by 32. I can imagine something like that here. And this is like on the border of passing or not, usually for constraints of 100,000, but likely will not pass unless you have some very fast algorithm for some reason. Not yet. So here I imagine we have this like wheel of those legs of a flower.
Yeah.
So, and then from every vertex you will visit those and also the rest of the wheel, maybe also hitting here or there, and at least you will visit square root. Or this is if this is size of the
well, no, you will visit n nodes from each of the square root number of
because
of small wheels.
You will not stop here, or is there edge here or not?
Well, if you put an edge here, you will discard everything at the first. So you don't want to have an edge here.
Okay,
actually.
so there is no edge here. Yeah, that makes sense.
So,
I think then yes, it can be done in such a way that here we will visit everything and we will like enter every leg, I guess. Yeah.
yeah, one of the Okay.
So indeed, it isn't easy to create those tests.
No, it was actually a lot of the time was to design those tests and also design time limits exceeded solutions that we would want to discard to make sure that because there is so you see that we cannot discard something just because it's quadratic, because it's hard to make a test case where something is really quadratic.
Yes,
you have to be more careful than this.
You need to often just think about exact particular quadratic solution in order to make it fail.
Yeah,
and then it's very hard to predict what everybody will get. And here's the current standings. Yeah, math from Zurich, they solved one more problem. Now in the third place, several teams with 7 problems. I think the standings overall look quite nice, with some like not linear, but there are some teams with every number of problems right now. So will we get 12 problems or not? What do you think?
My hope is that we have something like last year where there is some very last minute submissions that change everything. That will be really nice. Actually, it was pretty nice. So what we see is that, okay, we had several problems that were easy. So we should not be fooled by the fact that there are already 9 problems solved.
Yes, that's right. B and I are like 1 minute problems.
Yeah. That being said, so D, once you find the correct solution, it's and you implement it in the right way, it can be actually quite. D is the problem about DNA.
Okay.
It can be actually solved pretty fast. So I think maybe if they have not solved this, is that they don't have the right solution in mind. So E is more. You have to find the right algorithm, but then even if you have, it's pretty. It's harder to program the solution and to make it work correctly and to make sure that it scales nicely. And finally, H, I don't remember. Can you?
H is the one about random number generator.
Okay,
and
so
here on the stream we already talked about the solution, and it is quite unusual. You need to see something like that before to try to use.
Yeah, we already saw 2 teams solving it, so it's not that hard. It's not that complicated to write. But if you are too focused on usual problem solving, then so last year we had also an original problem, and the year before that also. And usually people tend to react weirdly to this. I would not be surprised that maybe. Some teams solve H, which is already the case, but those are not maybe the top teams, yes. And that will be something that we are looking for as judges. A perfect scoreboard will be a scoreboard where there is no one finishing or finishing at the last half hour, maybe, but almost finishing, maybe. and maybe different set of problems solved by the top teams. That would be something really nice.
Even right now, it's very nice that in the top, like first team, EP Chopper has problem L, but UPC1 has problem D. It's not just that it's very easy to sort problems by difficulty and everybody solves everything in the same order.
Yeah, but this is not the case. We see in the top team that it's pretty different. For instance, L, it's pretty hard if you don't already know the techniques, you know.
Yes, so L is like some knowledge from number theory and you need to know that.
Yes.
And I wouldn't expect anybody not from the top to solve L.
But even H, I mean, even H, if you have, you have already discussed about the solution of H?
H, yes, the random number.
So if you have never seen the tortoise and an air solution to a problem, which is, I mean, quite usual if you think about row polar or factorization or then if you don't think about it, it's pretty hard because the problem is made in a way that it's not really possible to compute on your local machine every value until the period starts. So you have a memory problem even if you do the pre-computation.
Okay.
So you have to be smart about the fact that you need pre-computation, but also about the fact.
How to do it exactly.
Yeah.
Like not to store everything in memory. Yeah, we even discussed that in the stream, like to maybe do some hacks, like only care about first numbers smaller than 1 billion. And only marking those as visited, not to store everything.
Or maybe store, you know, a hash table where you store only when it has some property of numbers, and then you check that you have the right number.
Yes.
Or, we had a problem similar to this, but different and not pre-computation last year. And for E, E is, I think E can be solved. I mean, we have several solutions. And I think the contestant can find the solution, but it's pretty hard to
E is about the game of life, right?
Yeah, no, not the game of life. You're confusing with another game. On GNOME, it's called Lights Off.
Lights Off, okay.
So
when you click something, the 4 adjacent cells, they turn...
They switch.
Okay.
And also the button on which you press switch. So you have a cross that switch. And basically you need to find where to push to get the drawing. Okay.
I was going to explain that later, but if you're familiar with the problem, then it would be best
to talk about the most familiar one is the one that just got away, but I can explain. I mean, I've looked at the problem. But you can explain it. I mean, you do a fine job of explaining.
So we have like more than 1 hour left, so we will do that later, I think. We still have time. Yeah, so...
In fact, there are 2 solutions in public mirror.
There are 2 correct solutions for E in public mirror. Cool, but not from the top teams. That's interesting.
So that's interesting part of the public scoreboard is that maybe people are reusing codes from elsewhere. Because it's... So I don't want to spoil the solution, but you can use code that you have written before.
Okay.
One team registered especially to solve this problem.
There is a team in the mirror contest, if you scroll there at the very bottom, that just solved E and nothing else. Well, this is what you can do when you don't participate. You read problems and then one looks interesting. You want to check if it passes or not, then you just register for that mirror contest and submit. There is no penalty for being low in the leaderboard.
Yeah. Okay, one other thing that maybe you discuss is that what we are very pleased that all teams solved problems, almost all teams solved problems, and a lot of teams solved several problems. So.
Yes, it's sad if you go to some competition and then solve nothing, and it happens, and it's hard to predict, especially if there is like big difference of skills between teams in the top. Those usually they practice a lot. They practice weekly, solving some old contests, solving a lot of problems. Then there are people in the bottom, usually some programmers that don't have a lot to do with algorithms. And then it's hard to provide something for them. And this is why problems like B and I exist. They are very easy for people in the top, and for the bottom it is about programming, it is about implementing something described in the statement. So yeah, that's cool to see everybody solving at least one problem. Also, each problem being solved by someone, and perfectly, nobody will solve everything.
Yeah, that would be perfect. Or just at the last minute, just like me last year.
Yes, last minute submissions are also cool. So in the last hour, we will have the leaderboard being frozen.
Yes.
Is that correct? So we will not see the verdicts of submission. We can still cheat a bit by looking at screens of people in the top, or if you see somebody submitting and then chilling out for the last 10 minutes, they solve the problem.
Yeah, probably. Or they know that they didn't solve the problem and cannot write the solution in 10 minutes.
I already saw submissions where they only say, see out, this is not a correct solution or something like that, and this is the whole code, just to stress other teams, just to make them think that you solved that problem.
Oh, that's...
It's not forbidden.
No.
And it's also to throw them off in terms of which problem among the remaining hard problems can be solved. Okay.
But I would worry about the last hour. Some teams are very active during the last hour.
Oh, that's for sure.
I mean, last year ENS won, which was a different team back then, I think. I don't remember exactly. They did a lot of things during the last hour. So we will see what happens. It will be nice that a different team wins this year, but...
Like for people in the top right now, we can expect that most of them, they work on 3 problems right now, unless they cooperate in some way. Like 1 team member per problem, and then it is even possible to solve 3 problems within like 10 minutes span if they just like submit at the same time, because one person finishes their code, the other fixes a mistake, something like this.
Yeah.
Yeah, so
but they have not tried anything for the moment, so we don't know what they are looking.
Let's get their screens of EP Chopper. To see what they work on. We also will see what files they opened. This is h.cpp, but already also just starting. There is some start cycle constant. We don't see it right now, it's somewhere at the top of the screen. But if they have start cycle and length cycle, I think they are good.
Well, they also need to have some intermediate values.
Oh yes, that's true. But they are on the right path.
Yes.
And they're on the screen now, on the camera.
Oh, and they are on the camera. We can, for a moment, also hide the screen. Yes, it's EP Chopper. They were also winning, at least for some time yesterday during the practice session. We see one person looking at on paper, either debugging, looking at some printout code, or maybe just thinking about the solution. And 2 people are
I think I am seeing a problem E.
From the drawing?
Yes, from the bottom drawing.
Okay, so yeah, so we see one person thinking about I, also talking with a teammate. Yeah, and this is what you would expect in close to the end of the competition. There is some cooperation, still maybe doing more than 1 problem, but not necessarily 3 of them.
Yeah, you see this.
Yes, at the bottom of problem E, there are some grids like that. Drawings are very useful. It's good to visualize stuff. Let's get back to the screen. That was EP Chopper, and the other team in the top is ENS, UPC?
No, not ENS, UPC, I think. UPC1.
UPC1. Let's see what they are doing right now. They are on the 2nd place. Something with a grid. Valor. So which program is that? We see h.cc on the left, but on the right it's something different.
It's E, no?
We are trying to guess here.
Oh, maybe it's L.
Maybe L?
No, I cannot see what it is.
Well, L indeed has a grid. It's quite long. Masquid. For a moment we saw the top of the code, but it was too
anyway,
short.
they are near submission. I mean, the file is pretty long, so I
Yes,
guess
yes,
we can expect a submission.
Sometimes after you're done with the code, then you spend like an hour debugging something, like if the sample test doesn't work, but then you pass the sample test and there is a submission. I think L, is it easy for mistakes in L? I think there is, because there are just two sample tests and the answer is yes or no, kind of, first player or second player. If you mess up something, even if you print like random value at the end, you have 25% that it will work for two samples.
Yeah. And it's not easy to create samples that are big and yet you know the answer.
Yes. Here it might help to, in this problem, maybe create a brute force and then test on some random tests or not.
But then your random test need to check the input format, which is...
Okay, the input format is something very specific here. Yeah, that's bad.
Or maybe you can expect that you have the same understanding of what a test is, and but then you are not testing exactly the same kind of...
So then this is a problem where if you get unlucky and don't get accepted on the first try, you have a hard time.
Yeah.
This is often the case with hard problems.
See out. We are up to see out.
First player, yeah. So at least we know now that it's this problem. So first, second, like, good idea not to repeat the same words twice. Again, not copy pasting from the statement. Let's see if there is some typo. Player will win. I think it was fine. We see a make, compilation, some debugging, and let's wait for a submission maybe, hoping that they will pass the sample test.
So will they move to the top position if they submit this? Or?
I think yes, but because two
already...
teams on the top, they have 9 problems each, right? There is some time difference. So if there will be the same number of problems solved at the end, the total time penalty matters. Is there a submit? No, just input. Yes, they download the input. Again, it's good not to retype everything and just make a mistake unnecessarily. The answer for the first sample should be first player win and then second player win.
Ooh, that's bad, no? Yes, that's bad.
Second player twice. Yeah, that's bad. There was here some typo in the statement, but it's correct in the input files, right?
Yeah, we see here that it is correct. Well, it's small, but it seems correct.
So now whoever is trying this problem should analyze this test, maybe use prints for some debug.
They are lucky that they have the wrong answer on the small test.
Yeah. Oh, because the second sample is 10 by 10, the first one is 3 by 3. Those codes in competitive programming are usually very ugly because you use short variable names. You want to make it correct and that's it. You don't want to support it for the next years and understand the code for...
Okay, I think we are on for some debugging.
Yes, CRR graph, print some values. Yes, you should print a lot of stuff. If somebody else needs a computer, you just print that. Otherwise, analyze it with computer and see where is the first moment where something strange happens. It is perfectly possible, for example, that answer was initialized to 0 and then never changed. And then maybe they say if answer is 0, then second player wins. We will get back maybe to this team later. And now let's see just the top teams in some from the 1st to 10th. Yep, EP Chopper here again, working on E. And does this work? If yes, then maybe let's stick to them. Do we have submissions?
So that H,
yes.
We will see the submission. No? Oh, they will.
they are testing maybe the running time.
But I fear this is. I fear this is a time limit exceeded
They
solution.
don't have any pre-processed values, but maybe we don't see them at the
Well,
top.
they have only the start cycle and the length.
Oh, okay. So their complexity will be all of the cycle of cycle, well, plus start. And this is too slow. Yeah, it looks like a few seconds.
As are not using time to measure
but
their
they will-
solution.
Yeah, they should use time.
So we will see. Maybe I'm wrong, but or maybe our tests are not strong enough. But I fear
They try to submit. What is the time limit in this problem?
it's very low. It's 0.3.
Oh yes, it's 0.3. So this is why 300 million isn't so promising. It's pending, and we already see wrong answer. It's not even time limit exceeded.
It's wrong answer. Oh, well, that's even bad. That's even worse.
Yeah. They have an ability to check if samples are correct. That's cool. So let's head for a break, or do you have some other comments here?
No,
about
but
the-
I was wondering if maybe someone else can come and comment on other
Yes,
thing, but
sure.
maybe later.
Yes, again,
Okay.
like we will now make like 10-minute break from commentary, and then we'll get another judge hopefully.
Yeah.
Great, thank you.
Thank you.